Hello, so today we're going to be covering application of factor formula. That is, we're going to use it. We're going to do application of factor formula in solving proofs. Okay, so let's start. Now we have this question saying sine theta plus sine 2 theta. This question saying sine theta plus sine 2 theta plus sine 3 theta out of cos theta plus cos 2 theta plus cos 3 theta is equals to tan 2 theta. Now, the first thing we say it is usually when you have these trigonometric equations and you have very many, because you have sine, 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 and cos, cos, cos. So you try to look at the angle and see, can I try to pair these angles in a way that can allow me factorize after? Because here if you say theta plus 2 theta, you get 3 theta divided by 2, you get 3 theta out of 2. Then this minus this, you get negative theta out of 2. So even so, you're going to be working with fractions. And for some questions, when you just work it out like that, it's going to give you the answer. But usually, you try to see, now here, if you see you pair theta and 3 theta, it will be theta plus 3 theta divided by 2. You get 2 theta, which is, there's also a 2 theta here. So the chances are, we shall have something we can factorize out and simplify the question further. So now we're going to assume someone just worked this out the way it is. So what do we have? You see here you have sine theta plus sine 2 theta plus sine 3 theta. So now here I didn't rearrange. We just say this is 2 sine plus sine is 2 sine cos. So this is 2 sine theta plus 2 theta out of 2 cos this. And even here I just say this is equals to 2 cos cos. This is 2 cos theta plus 2 theta divided by 2 cos this out of 2 plus cos 3 theta. So then I have this 3 theta out of 2. This is negative theta out of 2. And this is 3 theta out of 2. This is also theta out of 2. So alright, so here you see, you should note that the cos of negative theta is the same as cos of positive theta. The negative doesn't affect it. We looked at that and the reason. But now you see when you reach this part here, you stuck, because here you have plus sine 3 theta. Maybe you can try to break this down using the double angle such that this becomes 2 sine 3 theta out of 2 cos 3 theta out of 2. But now here it will be hard for you to break this down into one term. So I think you see that now this question becomes harder to solve with this following this way. But now let me show you here. You see when you rearranged it, when I rearranged it here, this is sine theta plus sine 3 theta plus sine 2 theta. After rearranging it, this is what we get. We simplify this, then we come up with this. But always note that the cos of negative theta is the same as cos theta, but the sine of negative theta is equals to negative sine theta. The negative comes out. So here we have this, then I factorize out 2 sine 2 theta up here, then I factorize out 2 cos 2 theta. So I get this and this cancel out. So this is what we get, 2 sine 2 theta out of 2 cos 2 theta. Final answer is equals to tan 2 theta. We've proved that. Here we have sine 3 theta plus sine 2 theta. Sorry, sine 3 theta plus sine theta is equals to that. So this one I think you can even pause and try it out faster. I'm going to just show us the answer. See? We go like this, simplify it, then here we apply the double angle formula. We get that we've already proved. Then now here we have sine 5 theta plus sine theta is equals to this. This one is also very doable. I expect you pause the video and try it out. So this is what we have, 2 sine 5 theta. You just apply the factor formula to both of these. You simplify, you see what we come up with here. This 3 theta goes, sine 3 theta, sine 3 theta goes, 2 goes, 2 goes. Then here we get 2 cos 2 theta out of cos theta. Now remember we said that cos 2 theta can be broken down into very many ways. If you remember our chapter on the double angle formula. So but here you see in the proof these are 2, so that's why we choose to bring in this one that has 2 cos squared minus 1 divided by cos theta. So we finally come up with our answer. Okay, now we're going to look at proofs involving angles of a triangle. So before we look at proofs involving angles of a triangle, we are going to first talk about a key principle, then we can continue with this. Okay, so before we look at questions involving angles of a triangle, I want to show you something. So if we have a question involving, maybe let's say a question says A, B, and C are angles of a triangle. So if A, B, and C are angles of a triangle, We all know that the angles of a triangle should add up to 180. For any triangle, a plus b plus c should be 180. Now, always, almost in all these questions, we are going to have an a plus b somewhere, and we shall have to substitute it with another term. So here it's a plus b is equals to 180 minus c. So we can now maybe say cos a plus b, because we want to replace a plus b. You're going to see in the equation somewhere. So this is this. Here we get cos 180 cos c plus sin 180 sin c. So we put in our calculators. So I'm simply doing this such that this becomes very simple for us. So this is equals to -1 cos c, and then sin 180. Sorry, then sin 180. This is 0, so the entire thing is 0. So this is negative cos c. So we have cos a plus b is negative cos c. But then for some questions we shall be required to have 2a, like we shall have maybe 2a plus 2b. So in that case, just come get this expression here. So multiply it by 2. So we have 2a plus 2b is equals to 360 minus 2c. Then we still do the same thing, cos 2a plus 2b. I don't know for some reason why it's commonly cos, but you can even do it for sine because it's just understanding what we're doing. So then this becomes cos 360 minus 2c. So this is equals to cos 360 cos 2c plus sine 360 sine 2c. So it's not just a matter of putting this into the calculator. So cos 360 is 1. So 1, then cos 2c plus sine 360 is 0. So this entire thing is 0. So cos 2a plus 2b is going to be equals to cos 2c. So meaning we got our question, and now we substitute wherever we're seeing cos 2a plus 2b with cos 2c. Okay, then now also another thing, this question can be when it's let's say from this a plus b is equals to 180 minus c. The question can be when it's a plus b out of 2. So we divide this by 2. So we get a plus b out of 2 is equals to 90 minus c out of 2. So this time I come and do cos a plus b out of 2 is equals to cos, and you don't have to cram these expressions. As I've told you, we started from this. You just have to know how to break it down, and here I'm doing this because I'll just be going through worked out examples, so it's easier for you to see from here. So you put this into your calculator, you see what is cos 90, and cos 90 is 0, so this entire thing becomes 0 plus what is sine 90. Sine 90 is 1, so this is sine c out of 2. So we get cos a plus b out of 2 is equals to sine c out of 2. So this is how we always going to have to substitute a term. Let's say cos a plus b with this, cos 2a with this, cos this with this. Now how about for the sines? I'm going to show us what we're going to have to, and for now I don't know if you just have to understand what we are doing. Then as we are doing the proofs, it will make sense why we had to do this first. Okay, now we are going to look at same aspect of the same thing, but this time how about like for the sine? So we said a, b and c are angles of a triangle, so a plus b plus c is 180. So this time I want us to make c the subject, and we are going to see why. So say a plus b, but we isolate the a plus b, so plus c is equals to 180. C is going to be 180 minus a plus b. So now this, because at a certain point we are going to have to substitute for c, because as I said the other time we saw cos a plus cos b, cos 2a plus cos 2b, and cos a plus b out of 2. So we could substitute for each of those. But for this time, I want us to see how to substitute for like the sine c. So sine c is going to be equal to the sine of 180 minus a plus b. So here we have this is sine 180 cos A plus B minus cos 180 sine A plus B. So the rest of the work is just for the calculator. So you see what is sine 180? This is 0. So this is 0 cos A plus B minus how about what is the cos of 180? The cos of 180, this is negative 1 sine. So we have our final answer as this is negative and a negative. This is sine A plus B is equals to sine C. Okay, now for some questions, we're going to have sine 2C or sine C out of 2. So we're just going to manipulate this at this point. So when you have sine 2C, we're just going to multiply through by 2. So here we get 2C is going to be 360 minus this is going to be 2A plus 2B. So what do we do? We say now we want to find sine 2C. It's going to be equals to that. Okay, so I have plotted this so you can see. So you can see here we have for 2C I expanded this and we get for sine 2C is this. And then I also went ahead and brought the same expression, but this time I divided through by 2 and we got this. So now what we're left with is just now looking at individual examples, and in a few this entire thing is going to make sense. Okay, now we're going to start with this question saying prove that if A, B, and C are angles of a triangle, then sine 2A plus sine 2B plus sine 2C is equals to this. So now for this question, the first thing we're going to do, we're going to apply the factor formula to these first two. Then we apply the double angle to that. So let's see. So you see we have sine 2A plus sine 2B plus sine 2C is equals to, I apply the factor formula to this. So sine plus sine is 2 sine cos. So I apply this and then plus sine 2C. So on expanding this is what we get. Then the sine 2C, I apply the double angle formula to it. So this is 2 sine C cos C. So then now that's when we come here from this to that if A, B, and C are angles of a triangle, then A plus B plus C is 180. So A plus B is going to be 180 minus C. So meaning we can find the sine of A plus sine A plus B. So this is what we're doing up there. And because I want to substitute for this sine A plus B, so eventually I have sine A plus B is equals to sine C. So now if I find that sine A plus B is sine C, I come and substitute for wherever there is sine A plus B here with sine C. So that's what we say here. We substitute sine A plus B with sine C. So now what was 2 sine A plus B cos A minus B plus C. So this now becomes, this is 2 sine C because I've substituted for sine A plus B. Then now I factorize out 2 sine C. When I factorize out 2 sine C, this is what I remain with. I remain with cos A minus B plus cos C. But now I want to substitute for this cos C. That's now how I come back here and say, remember, A plus B plus C is equals to 180, since these are angles of a triangle. Then now I put this into brackets, A plus B plus C. I make C the subject. Now I want to find the cos C because I want to substitute for this cos C. So I say cos C is equals to, then I expand from the compound angle formula, then I find out that cos C is equals to negative cos A plus B. So I substitute this in place of cos C, you see? Then I find this. Then here I apply again the factor formula. Cos minus cos is negative 2 sine sine. So negative 2 sine sine. And then from this, we're going to eventually have this, negative this. But now remember we said when you have a negative, like sign of a negative, the negative comes out. It's not like for when you have a negative angle in a cos, like it has no effect. But for a sine, so this will come out. Eventually it comes out. This becomes a positive, and just like that, we've proved that. So let's go to the next question. So this process is going to be repeating for almost all these numbers. Here we have cos A plus cos B plus cos C minus 1. So we apply the same thing, we apply the factor formula to this first two. So this becomes 2 cos cos. This becomes 2 cos cos. Then plus this minus 1. Now, we have to expand this cos C in a way that we can eliminate this one. Remember we said, and we are going to use the half angle formula, because remember when you look at the proof, you see you even have A out of 2, B out of 2. So we're going to use the half angle formula on this, that we have to choose an expression that can eliminate this one. Remember when we had something like cos 2A, we said we could factorize it in 3 ways. It's either cos squared A minus sine squared, or it can be 2 cos squared A minus 1, or it can be 1 minus 2 sine squared. So you have to expand it in a way that we can eliminate this one. You choose the expansion that can help us eliminate this one. So now here we are, cos A plus cos B is equals to, so now I say, applying the factor formula to this becomes 2 cos plus, now I expand this to 1 minus 2 sine squared C out of 2. Why? Because this can help me eliminate this one. This can go with this. So we have we now bring back, if these are angles of a triangle, A plus B plus C is equals to 180. I bring C this side, but this time I divide through by 2, because when I look at this I have A plus B out of 2. So that's why I told you have to look at what you want to substitute for. So then after this is a cos of this is equal to the cos of this. You apply the double angle, the compound angle formula here. So you get cos A plus B out of 2 is equals to sine C out of 2. So now we come back and we substitute forever. We see cos A plus B out of 2 with sine C out of 2. So you see, we substitute for this with sine C out of 2. And remember, this one goes with this one. So now we just have this. When we factorize out 2, sine C out of 2. So we have cos A minus B out of 2 minus sine C out of 2. So now we have to replace this sine C out of 2. That's why here I ask this question, what is sine C out of 2? That brings me back to this. So we say A plus B plus C is equals to 180. Then A plus B, I group it plus C. So I can take the A plus B this side. So C is 180 minus A plus B. Then I divide through by 2. So C out of 2, 180 out, everything divide by 2. So I have C out of 2 is equals to 90 minus this. But I want to find the sine C out of 2. So now I say sine C out of 2 is going to be equal to the sine of this. I apply the compound angle formula. Then eventually I have sine C out of 2 is equals to cos A plus B out of 2. So this is what I have. Now I come and substitute forever. I see sine C out of 2 with cos A plus B out of 2. So that's why I come here and substitute everything with that. Yeah, so after substituting with this, now we can apply the factor formula to this. So this is cos minus cos. This becomes negative 2 sine this plus this out of 2. Don't make a mistake, forget to divide by 2, because there are very many 2's here. You're going to end up changing the question. Even here, sine of this minus, but now when a negative enters this bracket, this becomes negative A out of 2 and negative B out of 2. So you have to be keen on the details. So here we end up coming up with negative 2 sine A out of 2 sine negative B out of 2. But remember, the sign of a negative comes out. So this comes 4 sine A out of 2. So we've proved that. So now we can look at maybe another question, and this sine A plus sine B plus sine C is equals to this. So for this one, I'm not going to go into the details, but just know the same thing. We apply the factor formula to this, then this we expand it using the double angle formula. So here, what do we have? We have 2 sine cos A plus this. Then now I bring back if A, B, and C, because I want to substitute for sine A for this. That's why I choose to say sine. So you expand, when you get sine A plus B out of 2 is going to be equals to cos C out of 2. So I substitute. So that's why I come here, and this becomes 2 cos C out of 2, because this is what we got, cos this plus this. We factorize out 2 cos C out of 2. Then we again have to eliminate the sine C out of 2. That's how we come here. And yeah, we find out sine C out of 2 is equals to this. Then I substitute it here. Then I again apply the factor formula. But you have to be careful with these numbers that involve halves, because it's easy for you to forget to divide by 2 because you're seeing this 2. Then eventually we've proved. So this is going to be our exercise. Prove that if A, B, and C are angles of a triangle, then cos 2A. So all these proofs. Now this one that has a 1 minus, what is the clue? The clue is that when you're expanding this cos 2C, you have to expand it in a way that the 1 remains this time. The other time we expanded it in a way that we wanted the 1 to disappear. This time we want the 1 to stay. So meaning we'll expand it like, this time we'll expand it like 2 cos squared C minus 1, because when the negative enters the bracket, it will become a positive. And then these others, I think, the very same concept. Then we can lastly look at this, prove that if A, B, and C are angles of a triangle, then cos squared 2A plus cos squared 2B plus cos squared 2C minus 1 is equals to this. Now, same thing for this question. You're going to have to remember a certain concept we talked about. When we were talking about the double angle formula, we say the double angle formula for cos 2C. The first thing we said is it can be written as cos squared A. So yeah, cos squared, cos 2A is equals to cos squared A minus sine squared A. This was the first one. Then we said it can also be written as cos 2A can be written as 2 cos squared A minus 1. Now, if I make cos squared A the subject, cos squared A, I would get cos 2A plus 1 and a half. Meaning, similarly, if I have something like cos squared 2A, I can take it back to this. I hope this makes sense, plus 1. Just the same concept. So that's what we are going to use for all of these. We are going to just use this proof from the double angle formula to substitute each of them with the respective, because when you look at the question, it has no squared. If the question maybe had something squared, but you can't apply the factor formula on things that are squared, so that takes it out. So you see, for this question, I applied that each of them a half into A plus cos 4A into this plus cos 4B. So now the rest of this is just algebra and how you choose to work it out. Me, I chose to factorize out a half, then added everything. I got 3, and this remained. I apply the factor formula to these two, and then this I expand it to this because I want this to have a negative one, which will add with this 3. So here I get a 2. Then after this I now open the bracket. This will multiply through by this, also multiply through by this, also make this 1. So now we have this. Then after this, we now go back to the same concept we had. We have cos 2A plus cos 2B. So this time when I'm using A plus B is equal to 1/8, I multiply through by 2 because the question has 2A plus 2B. Then eventually I find that cos 2A plus 2B is equals to cos 2C. Then I substitute. So you see that the concept is just very repetitive. Keep coming back to the same thing. So eventually you prove that. So that marks the end of the chapter on solving proofs involving the factor formula.